Hello! I'm making this as a simple guide to creating jigsaw block structures which can generate naturally in places of your choosing. Jigsaw structures might look a little daunting and they're not always immediately intuitive, but in the end it's a pretty simple process. In fact, all you really need to do to get it to work is little data pack. I'm going to include a link to my GitHub, which is where I'll be doing a bunch of showcasing online today. The GitHub is just for demonstration purposes. You can download the contents of it or do some copy pasting from it into a folder on your computer if you want to try it on your own world. The folder structure is going to be basically the same. Alright, let's start in game. First stop for many things involving structure generation is getting a structure block. So we're going to use that to create some structure MBT files, and while we grab that, let's also grab a jigsaw block and then a structure void block. There we go. Alright, let's build a simple little structure. So we've got this, and now what I'm going to do is I'm going to save it to file format. So let's place a structure block in the corner, and I'm going to press F3 and I'm going to check which way I'm facing to make the process easier, as it uses relative block coordinates. So you usually want it like this. You can see the thing in the center of my screen, red to the left, blue to the right, green going up. Alright, let's go here. Yep, I'm going to turn this off. We don't need that anymore. You're going to want to make sure that the structure block is outside of the bounds of the structure, because you don't want it inside, otherwise it'll just show up when you save it, and you don't... usually you don't want that. Alright, we're going to open it up, and here we have a nice little UI with a couple of options. The structure block has several modes. Right now it's in load mode. And what we want to do is we want to go to save mode. So bam, bam. Click that bottom left button. Now that we're in here, let's take a look at everything that's here. It's basically the same as what we had before. We have a field called structure name, some fields related to the coordinates, and then some configuration buttons, and what I'm going to call the action button. Before we name it, let's look at the boundaries. Let's go press done. Boom. There we go. And we press, by the way, we do press done because if you press cancel or you do escape, it's not going to save anything you put here. So we did done. And here we have a little wireframe shape. And it's going to help us visualize the extents of the coordinates that we defined. Keep in mind we are limited to 48 blocks in any direction. So 48 blocks that way, 48 blocks that way, 48 blocks up. So if it's anything bigger than that, it's just not going to save correctly. And it'll tell you that. So I'm going to readjust it so that this actually covers the whole thing. So in the X direction, the red, it looks like it goes to the edge correctly, but the Y and the Z, it's not. So let's go here, bring those up to 4 and 4, and bam! Now we can see the wireframe has covered the entire thing, and it also does not include the structure block, which is good. We also want that. Get out of there. Okay. I also want to mention that one of the things you can do instead of defining it like I did is use another structure block. For example, I would have put one in this corner and put it into corner mode, but I'm not going to do anything more with that because I usually prefer just kind of writing over this way. With the bounds of this thing set, I'm going to return to the UI and I'm going to go to structure name. So each structure file that you save, it's going to need a unique name that starts with the datapack namespace you want to associate it with. So what I'm going to do is I'm going to type in mine stuck. I'm just going to do baby house. Nice. I'm not gonna save it yet, but the reason I said that it needs to be unique is if you have other data packs or if you also have mods and they have the same namespace and the same file name within that namespace, then it's going to overwrite. One of them is going to overwrite the other. That can be useful if you want to make a data pack that overwrites like vanilla structures or modded structures, but it's really best to avoid unintentional overwrites. I'm going to be using the namespace mindstuck for everything in this video, but you can do your own. It doesn't have to be mindstuck. You can do whatever you want. Let's look at these config buttons now. There's one about invisible blocks, and there's one called detect, which is what you would have used if you used the corner mode structure block. And then there's one that toggles whether entities are going to be saved in the structure. Now, invisible blocks is going to refer to blocks like barriers, light blocks, and most importantly though, structure voids. Structure voids are useful when they're included in the structure MBT file. They allow that location in the file to not be replaced during generation. I find them useful placing them near the edges of a structure so it kind of blends in with the terrain. So being generated in like the side of a hill, you don't want to like carve out the entirety of that side of the hill. Unless, I mean, you might want to, but normally you don't. So you can use structure voids on the edge to kind of like round it out. But let's keep moving. Another thing to keep in mind is if you are doing this, make sure you don't have stuff that requires other blocks for support. So let's see if I extend this 2 blocks that way just for funsies. We have this tall grass here, or I guess just grass. You might see that we're not including this block here. So if I tried to generate this and there wasn't another grass or another dirt block underneath it when it generates, it's gonna break because it won't have anything. So just keep that in mind. If we want to actually save the structure, let's go back in here. We have the structure name, and I'm gonna go down to what I called the action button in the bottom right corner here. If we click it, we'll get a little message in our chat, and a new file is going to be created in our world folder. There might be some differences depending on the launcher you use, and I'm in a development environment right now, but a quick way that I use to get to the world folder is to go to the resource packs options and then go to open pack folder, and from here you can go up 1 directory space and then head into these saves. These are all your different worlds. Find the world that you're doing, so I'm in bunker testing, and go find the generated folder. Also included a screenshot with the basic file path that you can expect on the GitHub. Let's actually go there right now. Here we go. So saves, world file, generated, and then namespace, and then structures. Very nice. If you didn't, and by the way, if you didn't see anything, if you didn't see a generated folder, then you probably haven't successfully created any files, or you might be in the wrong world, so just double check. Alright, now that we have these files from the generated folder, let's actually move over to GitHub to explore the contents of the data pack. All data packs have the same basic layout. There needs to be a folder called data, and there needs to be a file called pack.mcmeta. Inside the data folder, you can find a bunch of different subfolders, each of which is going to have a unique namespace. And so let's quickly just look at this. The pack format is actually out of date for this, so you'll want to find out what's relevant to you, because that can occasionally impact things such as generation. But let's go open data. And here we see the namespace of Mindstuck that we picked. You can have multiple different namespaces here. Let's open it up, and inside each of the namespace folders, you can find a bunch of other subfolders and files, which will be interpreted by the game anytime the world reloads. Regardless of what your data pack is messing around with, whether it's recipes, loot tables, functions, world generation, what have you, you need to make sure that the folders here are named correctly. Otherwise, the game won't be able to find the stuff. if that makes sense. For a jigsaw structure, we're going to need the following. We're going to need a structures folder, and we're going to need a world gen folder. The structures folder is where we're going to copy paste our generated structure NBT files that we created earlier with the structure block. Using this screenshot as a reference, again, you'd find them in the generated, the namespace that you want, structures, and then you'd find them here. So in the screenshot, I have one called bush, but what I would have had was something called like baby house instead. And you also notice I have stuff called bunker here, which, if you can see here, I also have included that subfolder, and all these stuff are in that subfolder. The reason I embedded them one layer deeper in this subfolder called bunker is because you can have several structures in a data pack, and it's just useful to keep them organized like this. Alright, let's check out the WorldGen folder, and if we open it up here, we're going to find 3 subfolders. So let's open up this first one, and I actually have it in a new tab here. Bam, there we go. So in structure, there's structuregenerator.url, and then there's bunker.json. This file is what kind of determines what biomes the structure is going to occur in, and a whole bunch of other parameters. Importantly, the start pool, we'll get to that later, is going to be the template pool that generation kicks off with. We picked one that's called entry, but we'll go into more detail later. My understanding of size is it determines how apart, it seems to be how far apart the top and bottom of the structures can be, or at least how many jigsaw generation steps it's going to do. I'm a little bit confused on that, so you might want to do a little messing around. Start height is going to determine the Y level at which it's going to generate, and it's going to be relative to the next field here. Relative in the sense that it will try to place a structure on the surface of the world the way it was during world generation. So before any trees or other structures or stuff like that popped along, there is just a point on the ground, a Y value that's like, it says like, oh yeah, that'll be a good place to put it. And it's doing it relative to that, so 0 blocks. That means it's going to be right on top of the ground. If we want it to be buried in relation to the ground, we could put a negative value for this start height. There's a bunch of other things you can mess around with, and if you want, you can actually use this tool. I've included this in the structuregenerator.url. So if you download this and you're on Windows, this will allow you to automatically open up this location. It's very nice. It shows you all the things you can mess around with, which is very useful. Something I'm also going to note is that you're not limited to just this one biome. You can do a list of biomes, or you can have a biome selection that another structure uses, and that's determined by the has structure tag. But I'm not going to go into that just to keep things simple. It's very useful though if you want to look into it and you want to match your structure up to other existing structures. Alright, let's go into this next one, the structure set. We have open this tab here. Alright, and this takes the file that we were last looking at, the structure file, and then adds determines some additional placement parameters. If you're familiar with the JSON syntax, you might notice that there are actually there can be multiple structure files here, each of which has a different weight, which can determine its relative probability of being picked. In our case, we just have the one, so we don't need to worry about that. You'll probably hear this from every other tutorial that's like this, but you need to make sure that you have a unique salt. If you use a salt that another structure is already using, they're literally going to generate inside of each other, which is not good. Now let's bring it over to the template pool. I have that open here. Just like with the structures folder, I put all of these pools into a subfolder called bunker to keep them organized, just in case I add another structure to this data pack. Let's start by looking at the one named entry, which if you remembered when we were discussing the structure file, and the starting pool is, well, this is it. This is the starting pool. So if we went over here, here's the start pool. It's mine stuck, bunker, entry. And we see here in the template pool, it's bunker entry. So pools are weighted lists of structure MBT files. They can go through additional forms of modification, but I'm going to skip the details for this video. As with everything related to world generation, there's a lot of ways to tweak things, and one of the best ways to learn is to just mess around. There's a lot of useful guides online if you also want to learn more that way. Now, let's go to the pool called straight. Here we see it has some different structure MBT files, but it's basically the same format. Something you might know that's different is there's something written in the fallback field at the top. So for entry, we had Minecraft equals empty, which is just like a null, nothing there. But here we have minus bunker / small room. Basically, what this means is that if for any reason a jigsaw block has reached the end and it can't generate whatever it wanted to generate, it's instead going to try to generate what was in the fallback pool. Alright, we have an overview of structure MBT files and the layout of the data pack. So let's finish things up by connecting what we know so far with the remaining steps in game. So here we have a bunch of pieces, each of which is being saved as an MBT file. And before I go any further, a big shout out to TangleCat. She made all of these and more for the project Mindstuck, so huge thanks to her. Alright, let's move around and let's look at the structure blocks to see what these pieces are called. Each of these represent one of the structure MBT files I included on the GitHub. And as previously established, they're all going to be under the namespace Mindstuck, and also, as previously discussed, under the subfolder bunker. Let's go to this one first. There we go. So namespace of Mindstuck, subfolder of bunker, and then here's the actual name. So if we actually go inside one of these, we can see the star of the show, and that is the jigsaw blocks. A jigsaw block can be placed in a piece, which is essentially what I'm referring to as the physical manifestation of the structure MBT file. So everything in these bounds here. When information is stored in them, jigsaw block in one piece can hook up to the jigsaw block of another piece, and if their information matches up, it'll allow that new piece to be generated at the spot where the jigsaw blocks would connect. So let's go back to the top and think about it in different terms, and let's use the pieces in front of us as an example. So, when a structure starts to be generated, it first generates a single piece. This piece is going to be one of the structure MBT files from the template pool that was assigned in what was called the start pool. In our case, that's the pool called entry, which if we go back to the GitHub, we can see it has two entries. Either the piece called bunker durs entry upper will be picked, or the piece called bunker durs entry null is going to be picked. In game, the null piece is over here, but we're going to skip it because it doesn't lead to any new rooms and doesn't really mess around with jigsaws the same way. So once the first piece generates, the game's going to check for any jigsaw blocks contained within the new piece. Whenever it finds one, it'll check for the saved target pool. Let's go back here. So here we go. In our case, that's the pool called middle entry. It also has a target name saved. So what does the game do with this information? Well, it will go through the target pool and pick one of the MBT file entries. Then it will scan through that MBT file, and if there is a jigsaw block with the saved name that matches the first jigsaw block, what the first jigsaw block had in its target name field, then they can hook together and will cause the structure MBT file to generate as a piece at the same spot where those two jigsaw blocks meet. In our case here, we have the entry piece, entry upper piece and the middle piece, and they're actually next to each other to demonstrate how they need to match up. So we have this one here, and then now that we're in the middle entry piece, there's a corresponding jigsaw block which is physically touching that counterpart. Because we don't want new stuff to generate back upwards, our structure is one directional, and I'm going to refer to the first jigsaw block as being upstream, the second jigsaw block as being downstream. So upstream, downstream. The upstream jigsaw block will always have a target pool and a target name. And the downstream jigsaw block will only ever have the self-assigned name that matches what was put as the target name upstream. In which case, for everything in the project, it's going to be piece entrance. It is possible to have other configurations, but I'm sticking with this for the demonstration. And by doing that, we can keep things really clean and straightforward. Now at the bottom of the middle piece here, we have a upstream jigsaw block, which connects to the downstream jigsaw block in the lower entry pool. So in that pool, we only have one piece, which is this piece here. Now just like the middle piece, we have the one downstream jigsaw block. Here it is. But the structure actually branches out here at the bottom, and so there are 4 different upstream jigsaws. Each of them has their target pool set as connector and straight, which contains MBT files associated with these pieces, which, let's fly over to those now. So all the connectors here are lined up in a row, and all the straight ones are lined up in a row. And we can see this is connector 1, that'll be 2, 3, 4, 5. And this is straight 1, 2, 3, 4. Following the same trend, they all have one downstream jigsaw, but have any number of upstream jigsaws. So here's a downstream, and we can see it's actually no upstream pieces here. Here's the downstream, and we have one upstream here. The connectors are set so that they always generate a straight piece next. There we go. And the straight pieces are set up so that they always generate another connector or a small piece, and that's done through the connector in small room pool. And since we mentioned the small pools, let's actually go over to those. So looking at them, we can see only one jigsaw block, and opening it up, we can see that it is the downstream configuration, which means these act as terminal pieces, the end of the line. We can also see that other pieces over here, they're named differently. So if I go here, it's called lift. I think these are all the lift ones. There's, I think, another one. And they're named differently, but they're also actually going to act as connectors. Alright, now let's go to an empty spot. Alright, this looks like a good spot. So I already have the data pack from the GitHub downloaded for this world, so let's put all this to work. Now, there's a couple different ways to get a complete structure in your world. We could go to new chunks and try doing some natural generation, or we could use structure blocks or commands. So let's try the structure blocks first. I'm actually going to do a place, oops, not place. Structure block. Alright, now let's try entering. Mine stuck. Bunker. Now bunker. Durs. Entry. Upper. There you go. So loading from the structure block is a bit different from the other forms of generation, and it's not going to trigger the jigsaw blocks, which is useful so we can see the starting steps. So let's load. There we go. And load again now that it's prepared. Bam. Let's just delete that while we're at it. So I'm going to go to the jigsaw block here, and I'm going to set the levels to 7, somewhat arbitrary, but I believe that actually corresponds to the size value that I discussed earlier. And then I'm going to hit generate. Alright. So I'm not sure what goes wrong here when doing it through the jigsaw block, but I usually get misalignments that don't appear when I generate it in other ways. There's probably a way around it, but just wanted to show this off, and I'm just not going to worry about it. We allowed the jigsaw blocks to stick around, so as a result, we can see all these upstream jigsaw blocks paired to their downstream counterparts. Alright, by using pools, every time the structure generates, different pieces can get paired together procedurally, which can really do a lot to prevent a structure from feeling repetitive and stale when it's generated instance to instance. It's also important to be mindful of the shape and size of each of your pieces, as the game tries to avoid rooms generating in the same space as each other. In our case, that can lead to hallways that lead out into the ground, or, well, the air in this case. Let's look around. Very nice, very nice. More upstreams and downstreams connected together. Alright, now let's move a little bit farther away. And now let's try to use the place command. So we start to type it in. We're going to see that there's a couple of options. Feature, we're not going to worry about. It's kind of irrelevant. Template places down pieces from the list of all available structure MBT files, acting similar to structure blocks themselves. Jigsaw places down pieces from the list of all available template pools. Then we have structure, which places down everything as it would have happened naturally. We named our structure bunker, and it's under the namespace mindstuck, so let's try out the command. Mindstuck, oops, there it was. Mindstuck bunker. And let's just try that. There we go. When done this way, there won't be any jigsaw blocks left over, and instead they're going to turn into whatever block they were set to be replaced with, which is just air by default. I find it pretty interesting how much the size of the structure can vary depending on how quickly it runs into itself or how quickly it happens to generate a terminal piece. And now let's finish things off by looking at a naturally generated example. And here we are. It looks basically exactly like it did with the place command. This is actually the null variety, so let's try finding another one. What about you? Here we go. So it's going to look basically exactly like it did with the place command, but it's limited by biome selection, and it's going to use the spacing that was assigned in the data pack. Alright, if you have any questions or advice of your own, I encourage you to add a comment. Thank you for watching.